All right, diffusion is a property of gas that spread of one substance, usually gas or liquid, through another, right? So a drop of a purple solution, it just spread out later over time, okay? And the diffusion, you have seen diffusion many times. So all the gas from the industry, the hydrochloric and ammonia gas coming out. So you see it, all gas, it kind of vaporized, but not really, it's fly, all right? So now I would like to talk about the speed of the diffusion. It's speed too. Some people study it, right? So the diffusion rate depends on square root of 3 R. R is a gas constant. Temperature, that's T is temperature, over molar mass of the gas. Right? So you don't have to memorize this equation, but I want you to see what affects the rate. Of course, temperature. You increase the temperature, you increase the rate of the diffusion, right? If you heat it up, this solution, this purple solution will diffuse faster. But the diffusion rate inversely proportional to its molar mass of the gas. Right? So if a gas has a high molar mass, they move slowly. That's it. That's the whole goal, right? That's the whole concept. So if I have these three gases and these are molar mass of each gas, who moves the fastest? Who diffuses the fastest? Nitrogen gas. So because the smallest move the quickest, right? Carbon dioxide gonna be the slowest one. Okay, so some school have done this experiment. So, but we do online. We can't do it. So I'll just make a slide for you. Oh, let's take a look. So, the ammonia gas can react with hydrochloric acid through the air. I'll take a look right here. So hydrochloric acid vaporized, right? Coming up here. Ammonia also vaporized, coming up here, right? These two, when these two gases come into contact, they react and make a solid ammonium chloride. The white gas right here, these are not gas. Those are actually the solid sodium chloride, but it's light, so they kind of fly away, look like gas. Okay, so and we want to know who move faster, right? So we have like a tube, like a tube. Yeah, we have a cotton ball soaked with, one of them is on one end soaked with ammonia. The other cotton ball on the other hand soaked with hydrochloric acid, right? So this is in solution, and in solution, of course, the gas will move to that direction, right? All they're going to move to that direction. So the question is, where would you see ammonium chloride from? That's going to be the question, right? Depends on the speed of either ammonia or hydrochloric acid. If the hydrochloric move faster, go to all the way right here. So the spot of ammonium chloride going to be closer to the ammonia end. Does it make sense? If the ammonia move faster than hydrochloric acid, it's going to move quick right here. And ammonium chloride will be formed when these two come into contact. Ammonium chloride will be formed closer to hydrochloric acid end. All right. Now, who move faster though? Look at the molecular weight, right? So molar mass of ammonia, so molecular weight of 17.04 gram per mole. Hydrochloric acid, much heavier, almost way over double, right? So 36.46 gram per mole. Right? So 2 times lighter, so it moves faster. Okay. So the result of the experiment, so ammonium chloride is shown right there, closer to the hydrochloric acid end. See that? It's really interesting. Yeah. I really like this experiment because it's clear. It's not dangerous. We don't even use a strong hydrochloric acid. So, right, and you can actually see it. So it's kind of fun to do. Okay, so if you like cut it in half, right? So if I divided, so a little bit analysis right here. If I divided all the distance into 3 portions, ammonia travel 2 out of 3. So because ammonia is 2 times faster than hydrochloric acid. All right. Concept test. Why does the helium balloon leak out faster than the nitrogen? So we have a nitrogen balloon and a helium balloon. Time passed, helium balloon is smaller. Right. So it looks like helium atom move, right? I said microscopical. So helium atoms move out from the balloon faster than the nitrogen does. Well, look at who move faster, who diffuse faster. You have to look at the molecular weight, right? So the molecular weight of helium is only 28, but for nitrogen is 4. Oh, sorry, hold on. Sorry. Helium is 4, nitrogen is 28. So helium is 7 times faster, move faster than the nitrogen. Okay, so low molecular weight, move quick, diffuse quick. All right. So diffusion, we just learned diffusion. Now effusion. Okay, so effusion. I start with the definition: the process by which a gas escapes from its container through a tiny hole into a region of lower pressure. So we just saw earlier, those are effusion, not diffusion. So a little bit different, but again, both of them talk about how quickly a gas can move, gas molecule or liquid molecules can move. All right, and guess what? They have this diffusion, effusion. They have the same equation. Right? So it depends on the molecular weight, depends on the temperature, right? Graham's law of effusion said that effusion rate of any gas is inversely proportional to the square root of its molar mass. Well, we know it already. So I just showed you earlier. All right, so concept test real quick. So 4 container, all right? So we have 4 container. So we fill with a gas of carbon disulfide, carbon dioxide, propane, and a methane. Okay, which of these gases would mix with the air most quickly? Which would mix the most slowly? Right. So if we mix all this gas into the open container, of course the gas is gonna leak out, right? And then eventually they're all gonna mix up with air. But who move it quickly? Well, let's take a look at the molecular weight then. Who is the quickest? Oh, totally the fastest right there. Methane, 16 grams per mole. The slowest is going to be carbon disulfide. There we go. All right. Well, one more lecture. Let's go.